Welcome. In this video, we'll be talking about processing HTML documents, reading HTML data, processing HTML data, and uh, grabbing data content from HTML document. So this is important because although today many data providers, much of data is organized in machine readable formats, spreadsheet files, XML, JSON, SQL. There's still a lot of data, provided through the internet in HTML documents. So when we go process this data, this is kind of like reverse engineering the data generation process. Somebody has some data which they provided through an HTML document, and we want to go and get the data itself. We're not interested in the HTML presentation of the data. So let's take a look at an example we've seen before. There is a website that provides a list of the Georgia Bulldog team results over years. So let's take a look at the schedule, the 2019, for instance, football schedule at the University of Georgia. Now this website, which is still loading, will provide a list of the games in an HTML document provided to us on the browser, right? Now, we're not interested in all of the visual elements of this page. We're interested in the list of the games themselves and the location of these games. So there are some data components that we probably want to grab and clean up to create our master data set from this HTML document. Now, it will be nice if this data is provided to us in a machine readable format, but this particular website and many websites do not provide that. Some data providers, some mainstream platforms such as GitHub, as we've seen, provide two different ways for accessing the data, via HTML and via APIs, JSON or XML. But it's still true that many websites do not provide, machine readable access to their underlying data sources. So in this case, we want to go and grab the HTML page and process it to extract the data points of importance. So let's talk about HTML briefly. HTML stands for the Hypertext Markup Language. This is the standard markup language for documents designed to be displayed in a web browser through the internet. So any web page that you look at in your browser, it's written in HTML. So HTML provides a way to specify the content of the page, right? For instance, this is the content of the page I'm reading, but this content is also marked up to be presented in a certain visual style. Like for instance, this is the title, it has a certain style. This is the text. The first part of this text is bolded, right? The remaining of the text is not bold. Some part of the text are links, right? So in the underlying HTML document, the HTML language is basically specifying how this web page is displayed. In all browsers, you can go show page source, and if you do show page source, the browser will show you the underlying HTML document that to what we're looking at. Okay, so that's basically the HTML document which the browser will read to render and for us to see in a visually appealing format. So HTML, very much like XML, organizes the document in nested tags. So each tag has three main components: the attributes, obviously the tag name, the attributes, the text of the tag, and optional subtags or children tags. The difference in between HTML and XML is that the HTML tags, the elements, are predefined. They are designed to correspond to things related to the visual presentation of the document, such as links, images, text, paragraphs, bullet points, things of that nature. tables, which is a very important tag, especially because many data are provided in tables. So that's the main difference here. But the basic concept of tags and processing the document as a nested tree of tags still exists. So let's take a look at this sample HTML document. I just created this document in a text um, editor. And basically the root tag should be HTML. And the HTML document has two subtags, head, which provides some metadata about the document, such as its title, and then the body, which is the content of the document itself. So this body has a text, which is here the content of the page. There is a subtag, a paragraph, one paragraph, bullet points, then a table. A table has multiple rows, and each row has multiple columns. So there is column 1, column 2, value 1, value 2, the end of the table, and the remaining text of the document is the end of body, and then closing the body tag, closing the HTML tag. This document, if I open in a browser, is going to be rendered by the browser based on the HTML syntax that I provided. So here is the content of the page. That's a paragraph, 2 bullet points, and this thing is a table, right? And this is the end of body. Now, it doesn't look very visually appealing, such as the documents we access, because this HTML is missing the styling information, which is provided in a separate uh, uh, language, many often in a separate document called a cascading style sheet. But that's not important for the purpose of data processing. For the purpose of data processing, the data itself is all in the HTML document. The styling information is not important. So what we're going to learn today is how to process an HTML document using a library called Beautifulsoup. So Beautifulsoup is very much like Elementary, allows us to parse HTML documents. I mean, actually, Beautifulsoup also allows us to parse XML documents as well as HTML documents. So in a way, it's kind of like a superset of the Elementary package. So when we take a look at Beautifulsoup, so the difference is that Beautifulsoup is not built in Python. We need to install this package if we don't have it installed. So if you don't have it installed, you need to pip install Beautifulsoup, Beautifulsoup 4 to have it ready for you to be used. So if you don't have it and you have Anaconda, you can run the command here, exclamation mark conda install Beautifulsoup 4, or you can do pip install Beautifulsoup 4 if you don't have it installed. Okay, now I have it installed and I have imported request, elementary, but most importantly Beautifulsoup here. Here is my HTML document. For now, I'm dumping it in the notebook. From a Beautifulsoup perspective, you need to have the content of the document. Obviously, if the document is on the internet, I can grab it using a GET request, using the request package. Okay. Now again, we have to differentiate between the data format and the protocol that the data itself is being delivered through. The data format here is HTML, and most likely it will be delivered through HTTP, but not necessarily. The HTML file may exist on the hard drive, may be dumped into the notebook in a string, but the data format is HTML. So let's start with a simple example, and then we'll see how we process the data by grabbing the HTML from the internet. That's the HTML document, and what I'm doing here, I'm processing it using Elementary, right? And I'm doing this just to show you that in very simple scenarios, we can use Elementary as a way to process HTML documents, because HTML documents are very similar to XML documents. So I can create a root of the tree, I can go over each of the columns and print their text. Now, we don't want to do this all the time, and the reason is that HTML documents are not always well formatted. See, in XML documents, because they are mostly geared toward presenting, storing data, there is a great emphasis on the data providers providing well-formatted documents. HTML is not the case. Actually, the web browser itself is very kind of lenient in processing the documents. Like even if I forget something, even if I forget this HTML tag here, the web browser still can figure out that, well, it's missing, no big deal. I'm not going to throw an error, right? And again, this is probably a good decision because this document is designed for visual presentation. Even if there's something not, you know, well present, not very kind of tied down, it's still okay for a human reader to read it. Let's say I forget the end of the paragraph, or let's say I forget the bullet point here. Okay. If I do so, well, let's read the file another time. Again, no big deal. The browser probably figured out that, like, yeah, this guy, the document is missing a bullet point. There is another bullet point. No big deal. I'm going to substitute it. So the browser is very lenient in dealing with HTML, provided that we know that HTML documents are created by, many people who are not developers. They're created by designers. They're created by using multiple tools. So the browser is very flexible and it's not really picky when it comes to parsing the document. Well, that's not the case with XML, because if XML, if this is data and there is something missing, well, and then the data is corrupt and we need to do something about it. So if I take my corrupt HTML document here and paste it here and try to read it through element 3, I'm gonna get an error here because this is not a well formatted XML document. Well, the tag in line 25, column 6, which is this one, is not finished, right? So I'm missing the HTML tag, I'm missing the li tag, the document itself is not well formatted. So that's why, although in theory it's possible to use element 3 to process HTML, we don't want to do it unless we're sure that the HTML document is well formatted. So maybe we'll try it. If it works, it works, but most likely it's gonna generate an error at some point, just simply because of the variation of the quality of HTML documents on the internet. Okay. So let's go back to the presentation here. I'm going to do the same using Beautifulsoup. So Beautifulsoup is a library that parses HTML and XML documents. For the purpose of this presentation, we're interested in parsing HTML, and that's why the optional parameter here is HTML. Obviously, this is a variable name. It can be anything. Called it HTML. It can be doc or X. And then we can do something very similar to element 3. I can do find all TD for all columns and print the element of the text. Okay. So the functions are very similar. They're not exactly the same. This one is called find all, which finds all tags in the document. Now again, let me illustrate the point here. Say I mess up my HTML document. Element 3 is going to choke on it. Beautifulsoup is not going to choke on it because it's lenient enough to forgive such inaccuracies. Okay. All right, so let's see what we have here. We have a function called find all, and this function will find all tags provided the tag, and we can do the tag.attributes. We can print the the text. We can print the attributes of the tag, and we can print the children tags of the current tag. Let's look at one element. So that's element. It's a tag. It's an HTML tag. And this tag has multiple functions and multiple attributes that allows us to probe into what's inside it. So I was looking for attributes here, which is empty. Say for instance, let's print element.attributes here. Obviously there are no attributes in the TD, but let's say one of this has an attribute. Let's call it header. which is not the right way to do a header in HTML, by the way. It's just an example. For doing a header, there is a tag called th for table header. But for the purpose of this example, I just want to show that we can extract the attribute and the text from each tag, very much like what we do with elementary. All right, so what am I doing here? This is a function just to process all of the HTML document. The function is called print HTML3. It's printing the content of a tag. So what it does, it basically it prints the tag name, and then it goes to each one of the children, and then print the tree of each child. So if you run this function, it will basically print the whole HTML document, the structure of the HTML document for us. Now, this function itself is not very important. It's a recursive function. It's just to illustrate the concept that, well, we have different levels of hierarchy in the document, and we can traverse this hierarchy if we wish. Obviously, in many situations, we don't care about printing the whole document. We want to extract certain type of information from the document. So in the next exercise, I'm going to look at a document from the internet, and I'm going to process the HTML document from the internet. So this document, this resource, is basically our own MIS faculty directory. If you go to this web page, it's going to basically provide a list of the faculty names, address information. All right, while it's loading, let's take a look at what we're doing here. We are first doing request.get, and that's the URL resource. That's what we have done before. We're issuing a GET request, and we're waiting to the request to be delivered. We're checking the status code, and it's 200. Now, we can still check and see what we've got here. Content type. Okay, that's the content of the HTML document. I was looking for the headers, actually, I think. It basically says the content type is the text HTML. So that's an HTML document. And r.text is basically will give me the text of the HTML document. Okay, so if I print HTML, that's basically the source HTML of that web page. If I go to the web page, which hopefully has loaded now, if I do develop show HTML, show page source, that's basically the HTML text that I grabbed in Python. Same HTML text. That's the HTML document. All right. So let's take a look at this HTML document first. Well, now I'm again illustrating the point that elementary is very useless here because most likely it's not a well-formatted HTML document. Most likely there is an issue. Doesn't make a big problem in HTML, but XML document has to be well formatted. So what do we do here? We create a Beautifulsoup object from this text, and we can do many things. We can, for instance, look at all tags called TD in a table that have a certain ID name, and those will be the names of our faculty, and the titles will be all the TDs with the ID equal to title. Now, the question is, how did you know that your data is provided in a table? How did you know that there is an attribute called ID here? And this is the kind of the process in working with HTML document is very much reverse engineering. I need to go to my document here, and I need to look at how things are organized in the document. Like if I look here, there is a table, that's the table, and the table has multiple columns corresponding to the name, title, type, phone, email, right? So it's kind of playing around with the document and seeing how the data is organized. So I can skim through the HTML document. Like here, I can see that there is some header information. That's still the header information here. We're looking at the different departments. And here, for instance, it's still looking at some header information. Okay, here we go. Let's look at the content. Okay, so for instance, here is the main content here, people's name, informations, and addresses, phone numbers, and so on. And you can see that this information is presented in a table. That's a table. It has a header and t-head. There is one row in the header that has multiple columns, name, title, phone, and email. And then there's the table body. It has multiple rows. Each row has multiple columns, and the columns contain the data, right? And fortunately, the people who organized this made the nice choice of providing an attribute. So the column with an attribute name contains the names of people here. Title contains the title of the person. Type contains the type of the person. Email and address, phone and address. Okay. So what we're going to do, we're going to reverse, knowing that we're going to reverse engineer the document. I go back to Beautifulsoup here, and well, why don't you, if I am interested in the names of people, why don't I find all name? And you can see here that those are all the tags td when id equals name. Obviously, this is the whole tag. So if I'm interested in the text, again, I need, for instance, to take the first tag. That's the first tag. And then I need to do the text. So names contain all of the tags that match the search criteria. The tag is a TD tag, and the attribute ID should be equal to name. So we're basically looking at all of the names of the people in the directory. We're looking for this column. Okay. All right, so what do we do with this information? When we get the list of these tags, each element in the list is a tag. So element number 1 is the first tag, the first person that shows up in the table. Now this is a tag, so if I'm interested in the text, which is the person's name, most likely, I'm going to get text. If I'm interested in the attributes of that tag, I can do attributes, which will give me the attributes of the tag. If I'm interested in the children of the tag, which doesn't have any children, I can do get children or children to get the children. It's a list, but most likely it's an empty list. So let's see. Children, it's itself. So it contains, well, the children is one tag, which is basically the href, the hyperref tag to the person's profile. Because if I click on the name, excuse me, if I click on the name here, it's going to get me to the person's web page. So that's the href, the hyperreference tag within the name. Okay, so it has one child, which is the href tag, as we've seen here. Okay. Now we can do the same for title. So I can do that, and that will give me the title of the person. Sorry, that's the names, and titles, that will give me the title of the person. I'm doing some checks. Yes, names, length of names equals length of titles. So most likely I managed to grab the data in the table. So what I will do here, I'm just going to do some cleaning, put Humpty Dumpty together again. I'm going to reassemble the data. Starting from an empty list, I go over each name, and then I'm just going to take the text, strip it, go to the title, take the text, strip it, and put the stuff in a dictionary, and then append the dictionary to the list result. So why am I doing this? Well, I mean, I want to organize it in a meaningful way for me. So maybe a list of dictionaries, like a list of records, is a useful way to organize it. The other reason of doing it is that if I have a list of dictionaries, a list of records, I can easily convert it to a data frame, a pandas data frame. So I can do data pd data frame the result, and I can get a data frame here. Next, I can do all kinds of queries I can do with a data frame, like for instance looking for a subset using masking, like how many people are assistant professors, for instance. Last year we had 7, this year we probably have more. We still have 7. Okay, my bad. But it's basically looking for a title equals to assistant professor, and the sum of that is 7. So what we have done here, we basically looked at the HTML document, figured out the structure of the data, reversed engineer the data to put it back in a meaningful data structure for us to process. Now, the closing note before I leave this session is that if you're reading data from a table, such as what we have done here, then Pandas has a very useful function called read HTML. The function read HTML can take either a URL or the HTML document to read the HTML table and parse it in a pandas data frame. So obviously it's some more restrictive way to read HTML if your data is not in a table, if your data is in bullet points, if your data is in a different way of the page, then this function is not very useful. But if the data is in a table, which is often the case for many data sources, such as this faculty directory here, then you can immediately use the function read table, which will read all the tables in the page and give it to you. And the function is very useful because you don't need to grab the text. Well, you can read the table from the text itself. So you can do read HTML, and that will basically give you the list of the tables. But you can also provide the URL directly, and it will go get the page and parse the tables for you. So it's a very kind of a nifty function, very useful. It kind of eliminates all the different intermediate steps. That said, the intermediate steps are important for us because if this function doesn't serve our purpose, we need to go through these steps to get the data that we want. Okay, so let's do this. Let's do read HTML. And what I want you to know that this function returns the list of tables because a certain page may have multiple tables. Now this page has one table, but it's still true that this function is returning a list of tables. Each table is in a data frame. So if I want my table itself, I need to get the first table, I need to get the first element in the list. And this is the data frame that corresponds to the HTML data from the HTML, from the data from the table in the HTML page. So this function again is very useful, and it's like 90% of the time your data is in a table. You just do pandas read HTML and you get the data read and ready to be processed here. Once it's in a data frame, everything we learned about can apply. I can select, subset of columns. I can do all kinds of different data processing tasks that we learned about. So that concludes the discussion of scraping data from HTML. To conclude, there are two separate topics: reading the data and using the HTTP protocol to grab the data itself from the internet, and then processing the data. We learned about 3 formats: JSON, XML, and HTML, and those are the most common formats of providing data from the internet.